Welcome back to Foiling Week 2021 and the Gurit Forum. I am your host, Chris Museler, still reporting from Jamestown, Rhode Island. Apparently, the U.S. Passport Agency doesn't think Foiling Week is as important as I do. Anyway, my co-hosts, Bruno Gintoli and Laura Mariman, live from Lago de Garda. And we have this second session, thank goodness we were able to do two, for the SuMoth Challenge. And this one's awesome. We were talking about big picture things the last time in terms of what these universities and these students discovered and the applications that they're uncovering in that place in the world, how it has applications in our sport and in transportation and in composites. So we're learning a lot, but now we're going to talk very specifically about this challenge to build a sustainable moth and all the components of that with three separate 5-minute presentations. So there's just like, what do we call it? A sprint presentations. So right now I will send it over to Bruno to introduce the teams. And we have 8 jury members. I'm a jury member too. I don't feel smart enough sometimes. But we have Matteo Ledri and Michelle Marie here on the screen. And Bruno will introduce the teams and the jury members. And we'll start with the presentations. So right to you, Bruno.
Thanks, Chris, for that nice intro. So welcome everyone to the first stage 1 presentation for the SuMoth Challenge 2021. I'm super excited to see this team's presentation. So I'll start with the 3 teams that are presenting today. We have on site Politecnico di Milano with Beatrice and I. Then we have Domenico from Politecnico di Torino who will be presenting. We have Noah Ferrarotto from Rafal, unfortunately online. I hope they will be able to join next year live with their SuMoth. And I would like to present the jury. Actually, we have Luca that just joined. Luckily, yeah. Sorry, Luca. So we have Luca. To my right, I have Adriano. Laura Marimon.
I'm here. Hello, everyone. Hello, Chris.
Ciao.
And also on site, we have Mayel, Xavier, Benoit from SP80, who they were actually students who are now trying to reach the speed record. Kind of crazy, but they started as Matteo Ledri and Michelle Marie, who are also part of the jury. So as Chris said, the idea of this is sprint presentations. We're going to be letting the 3 teams present on their own. And at the end, we will bump with questions, I guess. If you all agree. Great. So we can start with Politecnico di Torino. They're closer to the mic. I think you can see them from on the screen.
I think, yeah. It's easy to.
Can you hear him? Yeah, can you speak?
Let me share the screen. Actually, there are 2 of us presenting, me and my friend Salvo Bucaria, who is responsible of area, dynamic area. Let me share this. See in the screen?
Voila. Awesome.
Okay. Good morning, everybody. As Bruno said, Polito Selim team moth prototype named Cat. Let me tell, we start talking about some history because in the farm of 2019 and due to the upcoming Foiling Week of 2020, the idea was to have an easy to manage, stable prototype. We tried to keep it simple. In fact, for material, we choose to use basalt fiber with bio-based epoxy resin, balsa wood as a core, and all things that we were familiar with, but also very good on sustainability point. And we took the Mach 2 rigs, and we choose to have simple geometries. Then we started doing some consideration. We asked, what if we set a different weight balance? What if we fly lower? These are questions that we have to ask ourselves, because we have to try as to bring innovation, and that's what we point at. And complexity. Thanks to the pandemic, we had the chance to dive deeper into the control system models and mechanics and all of that. We both rear and front control system. We tested new material application, and but I'll talk about this later. Let me leave the word to my friend.
Thank you, Dome. Thank you, Dome. We can go on with the slide.
Yes.
So as Domenico said before, the three main points we are focusing on in order to innovate the moth is the first, the weight balance. We want to have a boat as stable as possible, so we have to change the distribution of balance around the weight. We decide to put the 80% of the weight to the centerboard. So any single variation of forces the second point is the main foil control system that allow us to change automatically the altitude without any adjustment for the of the sailor. And finally, the fly altitude. We decide to keep it low in order to try to reduce the capsizing moment and having a more power in the sail, so the sailor doesn't have the need, okay, to depower the sail. From the flow dynamic and structural point of view, we compared lots of type of profiles from the commercial one to the homemade, and we decided an homemade profile that increase our efficiency. And the result is a very thin profile, as Bruno can.
All the people here.
All the people. So here in Lake of Garda, and so the structural analysis was very difficult. We introduced the linear and also buckling analysis, and I mean, in the hardest point, in my opinion, on this boat is the new flight control system. As you can see in the slide, the idea is to give a great variation of flap, of the angle of flap during the takeoff phase, while during while we are flying, the variation must be lower in order to avoid any disturbances on waves, etc. We obtain this by the optimization of a curvilinear guide, and the cinematism is something like you can see in the figure on the bottom. And then
my turn. For the hulls, we designed a lot of them on Maxer. Then we choose, and we try to. We were looking for something that facilitates a smooth takeoff. Then we choose 3 finalists, and we pass them to the CFD area, and we choose the best one in terms of efficiency. For the construction process, it's important to say that we tried to use. We decided to use balsa curve for the deck, because it was just a flat surfaces. Like I said before, simple geometries. But for the hull, we tried to apply PET, recycled PET, but we try to minimize energy consumption with the application of thermosheets. And the result is quite interesting, because we have to change the lamination process. We have to do it in 2 steps. That leads us to the molds. We really focus our efforts on molds because we looking at the SuMoth dollars, looking at how the competition is set, we try to minimize milling time and the waste of raw materials and the use of the raw materials as well. As example, we focused a lot on appendage molds. You can see the foil, the bigger appendage centerboard foil that we used three molds for it, two bigger ones for the two valves, and we introduced we call it the doof because it's a really fragile piece of mold. And in case of rupture, we would need to change only that, and not the entire mold. Further upgrade would let us will use a different material for it, like Teflon, and to allow a better only for doof, to allow a better demolding and that's all I think. For the molds, we use the polyurethanic tooling board and the wood panel. We used all of the depth, and to increase rigidity, we simply added wood panels on the ground to avoid the figures to fold. If I still have time, I just spend two words on the hull mold. We did a plug for it, and then a wooden plug for it, and then using the strip planking technique, and then we made the mold using the flax fiber leftovers that we used for very previous projects, and gel coating as well. In the end, it was interesting how we, I think it's interesting how we made the tramps and the wings, because we take upcycled broken wing surf masts, and it was really challenging to dimension them on a structural level, because they were all different diameter, no known number of plies and certification. So we had to do a lot of assumptions and deep measurements, and for now they are still holding. So I think we did a good job. Thanks for your attention.
Thank you very much for the presentation. Great. We're gonna move on to Milano. If you don't mind, you can also share the screen. We'll be also sharing the screen. So just for information, even if Torino managed to actually build their SuMoth concept, this evaluation, it's only for design. So Rafael, Milano, and Torino are presenting with their design key elements for their SuMoth challenge. Actually, Torino is trying to get on the water as soon as possible to try for stage 2, which is a GPS race against themselves, actually. So they need to fly over a course and register the fastest speed to create the log. Okay, so I'll be sharing. Yes, can you all see the screen?
I'm Beatrice. And I'm Maddalena. And we are from Politecnico di Milano. First of all, to understand about the general behavior, we developed a velocity prediction program in 5 degrees of freedom. After that, we dedicate ourselves to the research of materials that will make our project as eco-sustainable as possible. Our university has always tried to stand out for innovation and technological development. Following these principles, we decided to realize all the molds with glebanite. Glebanite is a fully recyclable material, secondary raw, that came from glass fiber. Glass fiber are sinterized and are recovered through pyrolysis of grass-reinforced composite materials at the end of life. The geometry of the hull and the waterline follow those of model already on the market, adapted and to be matched with various shapes of terraces and appendages. The terraces have been extensively studied and modified. Specifically, the transversal part and components has been designed to optimize the boat's aerodynamical performance. In addition to that, to recycling and reuse, these two components have been designed identical to each other. In fact, in this way, it was possible to realize both the components with the same mold. We also study how to adjust recycled and upcycled parts. In fact, longitudinal components came from carbon bowsprits used in the skiffs that we used for the Million of Vela competition. And for the trampoline, we used old sails that otherwise will be thrown away. And thanks to that, we have been able to give a second life to these two materials that otherwise have been wasted.
Talking about the foils, we focused our attention on the optimization of the keel foil and rudder foil. Our velocity prediction program gave us not only the optimal velocity attitude, but also the design and the geometrical parameters, such as horizontal areas, appendices distance, and rudder wake. Given the VPP results, especially the lift coefficient of the foils, an optimizer code has been written in order to find the best profile with a minimum drag and at the target CL. Again, using the VPP, we verified that this new profile provided us the best performance in most wind conditions. Later on, we proceeded a 3D analysis using a low-fidelity vortex lattice method. And we studied the stability of the boat, and we determined the plan form of the surfaces, considering the minimum induced drag, which means the lifted distribution closest to the elliptic one. Okay, so one of our strong suits are the sensors. In fact, from the very beginning, we realized that we didn't have enough experimental data to work with. And so we asked ourselves if we were able to get them. And our sensor team made a great job in implementing and designing an onboard circuit formed by accelerometers, anemometers, gyroscopes, and GPS. This all powered by a solar panel, according to our sustainable policy, I would say. And this is all included in the box positioned in the gantry. And on the boat, the data are shown to the skipper through a display. So the helmsman can see the velocity and the wing angles. The other data are collected and then used to be studied, I would say, and in a second step. And we hope that this advanced technology will help us to upgrade our projects for the future. We thank you for your attention.
Well, thank you very much. Great presentation. So we will move on to Rafael ETS with Noah Ferrarotto, who is awake. It's not too early, Noah, for you?
Oh, no.
So whenever you want, I don't see your screen share yet.
Yeah.
I don't think we see. Yeah.
Good?
Yes.
Awesome.
So please go whenever you feel like.
All right. Okay, so hello everyone, welcome. My name is Noah, and I'm a member of Rafale out of ETS Engineering School in Montreal, Canada. And I'm here to present to you Rafale 3, our third prototype after 2 successful C-class catamarans. We're rethinking how we build high-performance dinghies. So through eco-design, innovative manufacturing, and extensive life cycle analysis, I'm going to show you a bit how we went about it. So I'm going to jump straight into the hull design. So everything began with a survey of the forces at play, mainly the hydrodynamics below and the aerodynamics above, all that balanced by the righting moment of the skipper. Analyzing those forces allowed us to determine the optimal sandwich structure for the hull. So we ended up opting for a PET recycled foam core surrounded by 2 skins of basalt fiber infused with recyclable thermoplastic helium resin. The unique aspect of our hull is its fore-aft symmetry. So we actually made both halves in the same mold. So we had a mold with 2 bows, and we made the transom of each shell using a partition, so drastically reducing our tooling costs and associated environmental costs. Our foils are very much inspired by that of production moths. So we have an adjustable gantry system, and our verticals are made of a sandwich structure with a Corcel M60 foam in the center, surrounded by carbon fiber skins. So we spend a lot of time optimizing the wing, so the horizontal sections. So they were parameterized in StarCCM CFD software. And so that allowed us to determine, first of all, the optimal shape, angle of attack, wingspan, and flap angles. So from the results of the CFD, we were able to determine the optimal composite laminate for our stiffness during nominal flight, and that was measured through tip deflection. And then in extreme cases, we measured the strength by analyzing the root stress. So our horizontals, to make them, we had a bunch of pre-preg carbon fiber lying around from previous projects. So we opted to upcycle every material we already had on hand before acquiring new ones. So this leftover pre-preg was laminated into a thick slab and cured in an oven. And this cure cycle was simulated in Raven cure cycle software. So that's a tool that gives us gives us the confidence that we reach the optimal degree of cure for our cure cycle. So it's not only a software that can be used for oven cures, it can also be used as at room temperature. So it's definitely a tool that we'll keep using despite moving away from pre-pregs in the future due to their high environmental costs. So we will be using them for room temperature cures, such as the infusion of our hull. And we've also had help from some sponsors, namely Gurit Americas, who helped us machine the cores for our verticals. So every step of the way, we were doing lifecycle analysis to guide our design decisions and manufacturing techniques. So that allowed us to validate each and every one of those choices. And once we were happy with our design, we were then able to compare with other production foilers and see where we lived up to our claim of being sustainable. So we can see that we're doing pretty well with compared to the Equal and Mach 2 moths, namely due to our basalt fiber basalt fiber hull as opposed to carbon fiber one. But we're not yet on the level of the WASP because our foils are still carbon as opposed to aluminum. So the main lessons we drew from this were, number one, avoid prepregs, and two, explore more bio-based composites and try to find a better material to make our foils out of. And so with this in mind, we conducted a preliminary analysis for a future prototype, Rafale 4, and that will be used in the future to guide our decisions. However, right now, we are very much focused on the present. We're making progress every day towards the completion of our prototype. So we have a cured wing slab that's ready for machining into our wings. We have 2 hull shells that have been infused and demolded and now are ready to glue together to make our hull. And we have our verticals that have our core, and also our skins have already been laminated. So we're making good progress towards the completion of our prototype. And so we look forward to foil with you at next year's foiling week in 2022. And with that, thank you for listening, and I'd be happy to answer your questions.
Thank you very much, Noah. Great presentation.
Thank you.
So now it's the moment of truth. We can start with a round of questions per jury. Like each jury can ask the three teams one question, and then. So maybe we can start with Matteo.
Okay. Hello. I have a question regarding the foil development. So. For the Politecnico di Milano, I saw that you did some analysis with AVL, with the water lattice method, and while the others were using CCM. How did you consider the flap and the optimal flap angle during the optimization of the section? So you were comparing all the section at the 0 flap, or you were trying to find the equilibrium, changing the flap angle during the analysis of the different sections?
So what we did was we had 2 target speeds. So we had 6.5 knots for takeoff and a top speed of 20 knots. And so we made sure that, and we catted our wing with a flap angle of 45 degrees for takeoff, because that's what we found from the literature in production moths, and a 0 flap angle for steady flight. And so we made sure that the lift and lift over drag of both these cases was matching our target weight.
Okay, but the same question basically for all 3.
Same question for the 3 of you. Actually, Milano and Torino. If you can get closer to the mic.
Sure. Okay, here. It's okay here, for example. Okay. Well, in order to simulate and decide the design of the foil, also has developed the VPP, first of all, to understand the static equilibrium of the boat, and then we passed through a software that analyze the dynamic stability. In order to simulate the flap, we didn't simulate the flap like is in of the aerospace knowledge, and so we use the formulas, the relations, or of CL, etc., in order to change the angle of attack that is the same equivalent of the change of the flap. So we change the line of the CL0, something like this. Okay.
Okay, thank you.
This is okay.
Took in consideration the presence of the flap, and we studied it considering the wing and the flap beside it. The most problem we had is that we didn't have a relation between the rotation of the flap and during the sailing condition, which is also led us to to develop sensors with gyroscopes to know how actually the flap rotates around the hinge with respect to the tilting of the wand in front of the boat. That was one of the aspects we didn't know, and we didn't know how to manage it, and what we are going to discover as soon as our moth is going into the water.
Okay, thank you very much.
We can continue with Michelle. We can touch some sustainability aspects.
Yes, a very good presentation from all of you. A lot of different solutions towards reducing sustainability goals. One question relates to the hulls. I mean, obviously, you all have seen that the mold have a very big part of the impact, or the overall impact. Just one question: have any of you considered not using a mold, or using a male plug, which could have been made very lightly with strip planking, for example? I know one of you used that for the plug, but actually make it as a male mold and not go through the expense of doing a female mold on the basis that the hull is hardly ever in the water, therefore doesn't really need to have any fairing on the outside surface. Just a question for all of you.
Okay, who wants to start? We can go with the
So I would say that once we came across the concept of a symmetric mold, it was an idea that seemed like pretty new. So we were pretty enthusiastic about it. And so we definitely wanted to opt for the solution that, first of all, cut our tooling cost in half while giving us a perfectly fair surface finish. However, in the future, because the mold ended up being definitely in our top two, along with the pre-preg in terms of environmental costs. So it's definitely something we would consider in the future.
We use a mold, but it's fully recyclable. So we don't think that this could be a problem, and we didn't study any other options to avoid the use of the mold. In addition to that, even if the mold will not be possible to be fully recyclable, I mean, we study a shape for the terraces that avoid the use of one mold. So we use the same mold for the front part and for the other transversal part, and in this way, just with one mold, we can laminate the two parts of the boat, two of the main components of the terraces. But otherwise, we have a fully recyclable mold, so it's not a problem for us.
No, I appreciate that.
Can you share the screen? I'll just answer the question. Yeah, we noticed that the problem with molds is not just the raw materials, but also all the milling time needed to create it. So we tried to optimize it as much as we could, and we came with this solution that guaranteed a pretty good geometry and allowed us to save up to 600% of the. I mean, this solution is 1/6, 1/6 more sustainable, energy consuming than the milling one. So, in fact, we did.
It's a very good. I mean, your solution is a very good solution, and you could have. I mean, you could have not taken a plug or a mold out of the plug and actually used the plug as a male mold, which is the way we were building composite boat, let's say 25 years ago, without like using a male plug, not a female mold.
Yeah, it is. But the wood, it's really sustainable. The aluminum can be recycled, and we just milled or the section, and then we strip planked it, a bit of putty, and then sand a lot of time.
Yes. I appreciate you. You've done a good job in terms of coming up with a sustainable solution for female mold.
Thanks.
Okay, we continue with the. Just remove the screen. I would say Adriano. It's right to my right.
Thank you. Hello, everyone. I would like to ask a specific question to each team, if that's okay, Bruno.
Yes, please.
Okay. So I would start with Torino, first presenters, and you say that you started your designing process with a what-if question, and I would like to know, in terms of voice of customer, if you had the opportunity of discussing with some moth sailors and validate your assumption, okay, flying lower is eventually good, having a completely automatic adjustment is eventually good. Okay, those were your assumptions, but then they also became reality, means that they have been tested somehow, right? How have you made that testing?
You are right, because these are assumptions, these are hypotheses, but we want to innovate something, to change something. We started by studying the Mach 2 as a reference. And then we asked ourselves to push over the limit. And personally, with another guy, this is a mechanical one. I am aerospace. I have an aerospace background, so we studied together the control system, for example, and we are trying here on Lake here during these days to set it properly, and we saw that it is good. It is good for our weight balance, for sure. But I think, in my opinion, it is easy also to apply on other types of both. It only changed the main regulations, like I said. For the fly altitude, we don't know if it is right actually, because but on the paper we demonstrate that by reducing the capsizing moments, the sailor could have. I'm not a sailor personally, so I don't know if it's right. The sailor could have the chance to take advantage of all the power of the sail, and so increase the speed. Yes, during the regatta.
Yeah, if you ask the sailors about the if you want a control system that automatically adjusts, they would be kind of happy, I think. Yeah, most of the people we talked about were interested, and we tried to develop it.
Yeah, that's a good point. So if you say your control system is clearly providing a lot of gearing in the first 20 degrees movement of the wand, and then
you are graphed to
and then it's like going to be reduced the more the wand flick forward.
Yeah.
You have studied a Mach 2 with a bow mechanism 2.0. What's the difference?
Sorry, I didn't.
You own a moth in your team, right? Mm-hmm. And you own a Mach 2, which doesn't have a bowsprit, so it has a bow mech.
Yeah.
So if you compare the difference between your mechanism and the bow mechanism of the Mach 2, how does the gearing change on the Mach 2?
Yeah. Let me just a second to share the screen if it's possible. Yeah. Yes, we studied. Yes. We studied deeply the movement of the.
I'm sorry. I'm bad with this stuff.
Okay.
Anche la prima dicevo.
So we studied deeply the movement, so the change of the angle of the wand. So the alpha wand represents it is related to the. Si vede? Okay, so okay, so posso parlare o no?
It was really interesting, and I'm bad. Share screen.
My technical is not good.
Okay.
It's not, okay.
We got it. We got it. Okay.
I'm sure you spend enough hours that you know the system by heart, right? Oh, there we are.
Okay.
Okay. For this. Okay, as you can see, for example, on the right, we simulate the movement on the right. We simulate the movement of the perno. To say perno.
Axon.
Okay. on the guide, and then we translate it into the performance graph on the left. We can see that the alpha wand that is related to the fly altitude or mode. So when it is 70, it means that we are on the water and then we fly. While in the x-axis we see the flap, the variation of the flap.
Yeah.
So comparing our guide, that is the red line, with the Mach 2, we found that two main differences. The first is that the variation of the flap of our flap is limited between 0 and 20, as we designed at the beginning, in order to have the right lift, to modulate the right lift, while the Mach 2 can go also up. Okay, and the second main difference is the behavior of the curve. So we see that in the first part of the graph, so between 50 and 70 alpha 1, so at the beginning of takeoff, the variation of the flap is very high. So we increase our lift also only thanks to the increase of velocity of the boat. We know that lift is the velocity power to second power 2, while between, for example, 40 and 0, so the maximum altitude, the variation of the flap is very, very limited. So we can reduce the sensibility, for example, caused by the sensibility on the disturbances caused by waves or something like that.
Yeah, and
so that we have a more stable flight.
In the reality effect, I think like the Mach 2 is, as you say, in the first part of the wheel, very, very sensitive. So when you have to take off, you have maximum gearing. Then when you're sailing upwind, and so you have the one that, let's say, 45 degrees from the horizon, you have a very reduced gearing.
But you are talking about the gearing, so the system that goes inside the dashboard, or of the bow mechanism, because we
the bow mechanism.
So on the bow.
Okay. Yeah, we're speaking about that. And then when you are having the one perpendicular to the boat, you have again a lot of gearing. This is because when you sail downwind, you usually approach the waves from a different angle, and you want to have more gearing to maintain the boat stable and synchronize the movement of the flap with the waves. It will be very interesting, and I think a bit scaring to try your boat with some waves, and I'm very much looking forward to that.
Okay.
But well done.
But hopefully, yes, we have to be.
It was very, 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 very interesting to see that you engineer something completely new that has never been tried.
Thank you.
Milano, are you ready? Yeah. Absolutely. Okay, so in your report, you often try to source material, let's say, locally to reduce transport cost. Have you considered the cost of transporting the boat around the world to participate in races and similar events?
But we at the moment we don't have a bot, so we are trying to realize that. But usually we train on the interview that is very, very close to our university, and it's not a big deal, I mean, to reach the lake. And to reach Malcesine, we used more or less 3 hours, and that's all. We don't have any other CO2 emission or other things.
I think it's very beautiful that you have tried to design a front and a rear wing bar that are somehow using the same shape. And that is amazing because you reduce the stock competition. But as soon as you have to move that boat, having a joined right and left wing bar, it's going to create significant CO2 emission for transportation eventually. So that's also something to be accounted for. And very quickly, as a last thing, you mentioned as well that you spent time during customer interviews, and I would be curious to know, or like users interview, I would be curious to know what are, in your opinion, the main pain points of current moth sailing in the current setup and technology. So what are the main problems that moth sailors are facing today, and what have you done to create something innovative in that regard?
For what I've heard, the most common problem is the fact that the components are fragile, I would say. So very often they break. And of course, this is a cost in terms of material, energy, I would say also money. This is a thing that I would say the motor class should think about, because there is a lot of waste beside it. Like every time during a regatta that you break a foil or a wand or whatever, and you just need to throw it away and buy or make a new one, then all that stuff is really going to be wasted. And probably that is something that could be increased, because I've always sailed and I've really never met a boat which is so much fragile and needs so much attention. And I mean, where all the components are going to, you have to consider that they are going to break as soon as you're going to use them. So doesn't sound very good. And it's a big problem for all of us, not only for the sailors, because at the end it's all of us living in the same place. So probably we should really think about this.
Okay.
That's actually one of the concepts is trying to throw the least of the
Yes. Yeah, but that's a solution, I mean.
Of course, Bruno, without creating rooms and mass to use for your competition. So be very careful for what you wish for.
So now the next one for the hall.
Yeah, and then I'm done.
He told me you have really hard questions. And,
Yeah. Yeah.
I was actually trying to be fair.
Okay.
Well, okay. So for the guys of Raffaele, I was curious to know if you have some thought about what is the greatest weakness of your design or the greatest unknown as of now.
Yeah, I can definitely tell you that. So we're an engineering school. We are the closest naval architecture school is probably a few hundreds of kilometers away. So our hull design was done by reverse engineering, not by like ground up calculations. So in terms of like being rigorous with the design, I would say the shape of the hull, which is arguably good because it's been it's strongly inspired by that of the WASP. However, in terms of structure and optimization, I would say the wand control system, just because we did like a basic sort of motion ratio analysis. But again, in terms of like expertise in naval architecture, control systems, things like that, I'd say we definitely have a leg down on that.
I agree that the fall control system is a challenge, and if I have to bet my money on where the problems are going to be next year when we will see all the boats, most of the problems will be in the control system. Even because as long as the hull is not okay, you can overcome that somehow. And if you break something, you can always add extra layers of carbon. But sometimes, like making last-minute adjustment to the control system is tough. And do you have a plan to overcome this kind of risk in your project plan, or do you have some wishes?
We benefited a lot from the little master classes that we've been having. So discussions with experts in the field. So we've been learning a lot, and we have a plan to design a sort of more ground up system where we have a model for ride height, pitch, things like that, so that we have a bit more numbers to back up our design.
Yeah, that sounds like a solid plan. Thank you.
Okay, so we can continue. I think Chris had a question.
Yes, awesome presentations, by the way. It's amazing to me that on the sustainability side of things, how far the teams are just pushing things, but also you still have to solve the technical issues. And from Milano's point, I know from moths that they break all the time, even the current models. So you're thrown into a really awesome design challenge. And Adriano knows that the WASP is a secret weapon when it comes to these things, because it doesn't break that much. It's very robust. My question for everyone has to do with the tools that you are using for your engineering analysis and your simulation and for construction. So do you think that you have the tools? We know VPP for performance, but as far as construction is concerned, when we talk about recycling materials and upcycling materials, Torino said, we don't have specs on some of these broken windsurfing masts. Do you have the tools you need to use recycled and upcycled material that you're pretty confident it won't break? Or do you think that's one of the unknowns in the design challenge of the structural elements being recycled or upcycled? Like, do you have the tools to analyze recycled material in a way that you can trust it?
Start with the piano and then.
Talk about my ship.
It seems to me that's the limitation of using recycled material, not knowing the strength of the material.
I don't know if we really have the tools to do this kind of analysis, because they are really, really, really complicated to do. A life cycle assessment is something not banal, and but we plan to do it, considering everything. And marine ship. Can I talk about marine ship? No, okay. No, the SuMoth dollars helped a lot, guiding us in this project. But we also used a lot academic articles that are. It's a quite slow process, and it really slowed us in our decision, because it's not so easy to find answers, and most of times they are not good for a preliminary analysis, but for a life cycle assessment when you finish the project.
We starting our structural analysis developing a BIM model to understand the general behavior of all the structure of the boat. The principal problem is that we don't have the real load that works and deformed the boat. So that's why we choose to develop a VPP model. And for the hull in particular, we analyze some parts with simulation of the sandwich, and that's all. But I mean, it's not a problem just for recycled material. It's a problem in general that if you develop a structural model, it's just a model, and you have to trust. You can't trust the result that you have from this structural analysis, from this FEM analysis with, 100%. It's just a simulation. In addition to that, the boat it's not a static structure, so the FEM analysis it's just a simulation, and you have to balance the information that you have and what the software can do. Just not connected to the behavior of the raw materials, the secondary materials. It's a problem in general, I think.
Yeah, so I would say that we're very fortunate on that front because Montreal has many universities which with very strong composites departments that are working very hard with number one, recycled composites, and number two, biosourced composites. And so we've been very fortunate to have advisors that were sort of able to guide us through the process. But also, basically, when you have recycled, you're using upcycled materials, or for example, for recycled PET foam core, well, you get the risk of having a greater spread in your properties. So it could be very strong, but you might hit a bad apple that'll crack on you. So we basically took that into account in our safety factors. And in terms of upcycled materials, we're very lucky that the upcycled parts that we used were built by alumni of our team in previous years. So the information was readily accessible in terms of properties and structural integrity.
Great, thank you so much. And I'm not for this conversation fully, but I'm curious with Matteo, Michelle, it's a lot of extra work to do that trial and error, to use that upcycled and recycled material. If you don't have the data that Noah has and his team, it's a lot of extra work, but I wonder what it would take for America's Cup campaigns and other manufacturers to take that extra step to make that those secondhand materials, like Milano says, useful. So, thank you, everyone.
Yeah, I probably could add on your question, Chris. A question for all of you: Did you do any mechanical testing to characterize the material you were going to use, and to feed back to your
No. Now I think I get the question, because earlier before I thought that we were talking. You were asking about sustainability, and I answered that. And I can answer. have quite a good experience on dimensioning composite materials. Thanks to our previous project, we do FEM analysis using our sponsor Altair with solder OptiStruct, and for all the loads we use academic articles, but also we simulate, we do CFD simulation on all of it. We are also trying to do fluid structure interactions using another sponsor called Beta, and for now things are holding up, but we should focus more on the critical points and then the load conditions. To answer Michelle, no, I didn't forget the question.
If you try, if you use testing on the cycle.
Yeah. Right now we are recycling basalt fiber and glass fiber, and we are laminating it again to see the mechanical, to compare the mechanical properties. We are using a special epoxy resin. As a team, we do more projects and we share this kind of knowledges, and it's quite interesting when this thing is leaking. And for carbon fiber, we tested all of them, but I think next year we are gonna plan how we are gonna plan to test the recycled carbon fiber.
Yeah, we had some issue with the batteries on the
Ragazzi, c'ho anche 11%.
Okay. I'm from Politecnico di Milano, even if my name here is Politecnico di Torino. Okay. So about the materials, we didn't do any tests yet because actually manufacturing is in progress for our boat. But I don't know if I can spoil this, but we have a project to collaborate with a sponsor to develop some sensors that can verify the stress and the strain of the sandwich and structures in the boat. I think that this is because what you asked is what actually also we asked ourselves, and it's going down, and we came up with the idea that we could develop some sensors that can give us the answer and let us know what really happens inside our materials while we use our boat. So we're going to discover it, and maybe we're going to talk about it the next time.
So we've done a lot of testing, namely due to the helium resin giving us some releasing problems. So we've done like dozens of specimens for our basalt helium laminates, and we were very methodical along the way to sort of start small, make small coupons, and then make them bigger and bigger, all the way to a full shell, but only one skin. And then sort of all that was done before doing the first hull because of the expense of a potential error that could happen. So in terms of process testing, we've done a lot. We've tested a lot of release agents and different solutions for being able to use this elusive resin and fiber and core. However, in terms of mechanical testing, 3-point bending, short beam shear, peel tests, things like that would be very beneficial to back up our structural component, but that will be in future years. Yeah.
Okay, thank you.
Thank you, everyone. I mean, it's an important part of the process, and it's the start of the process, really, especially when you invest a lot of time FEA analysis. But yeah, very good that you onto it.
And I just had a quick comment. If this is an area where non-destructive testing is a possible application. And maybe that's very expensive.
Yeah. So we've had discussions for doing CT scans for bonding or ultrasound testing for voids, namely our carbon fiber slab. That's a very critical component of the boat that was done with very old material. And so we were considering potentially doing an ultrasound of the part. However, it is difficult to develop the right relationships and sponsorships and things like that. Great. But definitely potential.
I would recommend it.
Yeah.
I think I need it on my own body to see if I'm going to break when I go sailing that moth.
Okay, thanks for that question and the answers. We're going to move on to Laura, who has some burning questions on this.
Yeah, mine are more on the hydrodynamic side. The first one is specific for Milano. I see you've done a nice torpedo shape with the fish scale kind of surface finish, but then all your VLM and the X-foil optimization, that's for Reynolds number, which are in the transition between laminar and turbulent. So I was wondering, how much confidence you put in your design tools, and if you've done any further studies on trying to get this the transition right, or if you know where it's going to go turbulent.
Okay.
Yeah, it would be interesting to see when the boat is on the water, especially with all your sensors, if you can give an answer to some foil finish, for example, questions, because that's an area where everyone is still kind of looking at. And same hydrodynamics, I guess, for Rafael and Torino. But in the report, I guess I'd like to see some mesh refinement study, or some confidence in the CFD results. So I'm sure you did that, but if you can comment a bit more on the hydrodynamics, especially for the optimization of the foils and the flow around the vertical and the horizontal.
Yes, the CFD, if you want to
If you want to share,
If you want to share,
backup slides.
We prepare the right backup slides. Okay. Okay. So in terms of CFD simulation, like you said, we trust in our results, but we verify them. Better. The main goal is not only to develop an efficient profile that is not easy, but it could be possible with the CFD analysis and something like this, but also develop a profile that is functional with our architecture and with our concept of the boat. So first of all, we did the analysis every time. For example, we develop a new profile. We test it with the WPP, and in order to verify if it is good in terms of stability in our case or not. And at the end, we develop a homemade profile. For example, for the main foil, and also for the vertical part of the appendages. They probably are easier to develop because the profile has to be symmetrical. The great challenge this year for the moth is the simulation of the flap, or rather the decision of the flap and the variation, the maximum variation of the flap. This was the most challenging part in CFD simulation.
Yeah, Rafael?
Yeah. So I would say sort of similarly to our testing we've done physically, our CFD was very much a ground up process. So we started with just 2D hand calculations and then sort of moved up to CFD with finer and finer meshes. And so we started with a very conservative, for example, very conservative turbulence model with a coarser mesh to determine sort of the general design space. And then we used the parametric study to iterate through many different configurations of span. And well, we started with angle of attack and moved on to span to hit the right lift number, and eventually moved to a very refined mesh with a less conservative turbulence model. So to reach the agreement and then verify that it was in agreement with our initial, or in the range of our initial hand calculation.
Yeah, it's thank you very much. I guess it's quite difficult to model, yeah, in that transition region, even with the normal runs. So.
Okay, awesome. Thanks. We're gonna continue or maybe finish the run with the SP80 jury. Who, I don't know if we can get him with the camera. Well, yeah, maybe there. Yeah.
Not too far. You can go away if you want. Okay. Yeah.
Yeah. Yes. So.
I was on the other side.
Like to see your work, we were like at your place a few, actually, like 3-4 years ago.
Actually, Benoit is still a student. Yeah.
Yes, and we still have like a lot of students in the team, and it's like always nice to see all these ideas and experimenting things that like more experienced people would not think of, because like, I mean, and so I had a question. Like, because we saw in your slide, for example, that the main conclusion that you had about sustainability is that you should avoid prepregs, for example. And so I think it's a good point, because high performance is not going well with sustainability. I think we all know this. And like how, so it's a matter of balance, like of finding the good trade-off between sustainability. So if you want to do something sustainable, then you will have to sacrifice, for example, weight, or you will have to increase appendage thickness, and so increase drag. And so what was the workflow, or what was the methodology to make this assumption, these trade-offs in your design? How did you say? Because sometimes it's obvious, like what you can make. If there is something that is not sustainable at all and that is bringing low additional performance, then it's obvious you won't do it. But sometimes it's tricky to do the trade-off. So what tools and what methodology did you follow? It's maybe a general question for like all of the three teams, but
Yeah, that's right. Okay. Yeah, it's an interesting question, and it would be nice to see, first of all, an improvement, a compromise we choose was that to avoid infusion, because first of all we felt quite sure about our end-main layout technique. We improved it with kind of a pre-impregnated carbon fibers. So, and because we noticed that infusion it's really, really expensive in terms of sustainability. And it would be nice to compare the rest, to really compare the results between the types of construction process and choose the best compromise. So it's quite an hard question, I think. Yeah, the truth is that we mostly choose what we felt confident with. Yes. Okay, we know it would have been the most sustainable choice. So we said, why not? We feel confident. We are going to try infusion. We are focusing on the resin itself, and. But for the process, I think we had quite good results for now, and we are testing performances. I think I answered, I hope.
Okay, so this is a good question, of course. I would say that at the beginning we chose to concentrate our attention on the upcycle or recycled materials on those surfaces which we thought were less excited. So we prefer to maintain carbon fiber on the foils because it's where there are actually the major loads. However, the skin carbon we used are end-of-life skin carbons. So we try to contain our pollution in a way, and yes, of course, probably in the second step project we'll try to test some other materials also for those so much excited parts, but for now we concentrated on the hull and on the terraces, and for the foil we maintain carbon fibers, but we can do much better.
Yeah, so in terms of compromise, I'd say we had a very similar approach in that we found the foils to be by far the most critical region, so we stuck to carbon for those, and we happen to have all this very old pre-preg that we had to use, so we decided to go for that. Then, however, in terms of more compromise, I would say in terms of infusion, I would probably have a healthy disagreement with Torino, because although it does create more waste material and you need more resin, if you use a recyclable resin like we did, then all the resin that ends up outside of the part can be readily recycled. And also, it's an increasingly popular technique in aerospace because you don't need an oven, you don't need a freezer, and you can get basically void-free parts using more advanced techniques, of course, but it definitely worked for us on a smaller scale, and we will definitely be implementing it more in the future.
Any other questions from your side, guys?
Yeah, the question, this is a simple one. Thank you. No, it was each team pushed the concept and the development to different steps, and it was I didn't saw that in your report or in the presentation, but how many are you in each team, and when did you start working on the concept and the design? Because, for example, designing a BPP is quite long, and other team pushed to the construction of the boat. So, how many are you in the team, and when did you start working on the concept?
We are a big team. We are almost
Big family, I can say.
Big family. Almost 80 people, but because we are doing now 2 competitions, the SuMoth Challenge and the Million Black Cup, and we are building 2 boats this year, the Moth and Pilaros, another fantastic project, and the construction site guys are almost 10. Yeah, and in the periods of intense work, other areas try to help them, and because we believe that the construction part of the boat is the most precious one, even especially in these hard times. People, each other, and we use it to do team building and also to help we kind of force the people of the other areas to go there and at least have a look on how we build them, because it's very useful for the project areas. And yeah, we cooperate and we share knowledge between these 2 projects. And yeah, but if I have to quantify all the people that worked on the Moth, it would be 30 or 35.
Okay. And what was the time frame you expected to develop and build the Moth?
It's really hard to say because the COVID really slowed us down. Without COVID, I'm really optimistic. And in fact, I set the due date very early, and we thought we could have done it in 6 months. I mean, from nothing to in the water, well rigged, and it was quite yeah. We believe
it was challenging. It was challenging because it was the first time of developing a Moth. So we started the project 2 years ago. About 2 years ago, we started to talk about by design a new Moth. So we started the project. We understood the critical points of the design, a new type of boat, and then once the project was finished before the pandemic, but thanks to the pandemic we could develop more and more details about it, and then we started to construct everything, to build everything, and an important thing I want to say that during the project also the constructional area were inside the idea of the designer. This is why, because collaboration, but in my opinion it is important because the project, if we have to finish a project, if we have to have a boat into the water, we have to understand the critical points also of the construction at the beginning phase. So to have a balance between extremely optimization and reality of things.
Okay. Yes, in Polynesian sailing team we are around 30 people, and I would say that we started to work on this project from in September of last year, because in the year before we started working about it, but due to COVID and we didn't really manage to to begin the work in the proper way. So we started in September, and I think that the project and design, the engineering and design project was ready in time, but the problem we had was about the delay of the suppliers, because the material actually didn't arrive in time. And also our group is made also of people writing thesis for master degree. And that's a great help because, of course, we develop part which probably wouldn't be done in such a short period. So they give really a big contribute to the team. And that's what happened actually last year. Yeah, so it would say September till us, but the lot is not ready, but it would be.
We're really looking forward to see actually all the videos. We are extremely happy to have at least one from Prima. It's quite emotional for us, but we're looking forward for next year. Oh, 6 or 7. The next one for Rafael. I know you are not too many actually, but a couple of weeks ago, I saw a lot of people.
Sort of from the start, September 2019, there was about 15 of us, 4 people designing the foils, and then one guy doing his master's thesis, doing the hull and the lifecycle analysis, as well as many others doing sort of subcomponentry, treasury, communications, things like that. And in the natural adoration we find in design teams, we are now 3. So 3 regulars that put in the hours in the shop, getting the boat ready for August, for putting it in the water. However, we are very lucky to count on some people, namely our alumni, who we had a little reunion last week. So we had, I think it was 10 people in the shop. So we got a lot done that day, and we'll probably be doing another one of those, because without that, we would have a lot of difficulty between the 3 of us getting it done.
Awesome. Thanks a lot. So I don't know if there's any other questions from the jury. Otherwise, we're going to wrap it up. As the following part, it's going to be taking off all the assessment from the jury. We're going to announce the positions of the stage 1, and I really hope Torino can get their stage 2 measurements for as we speak. The rest of the team is working on that. So, any other questions? No, I don't know if they're listening. Hope so.
You're safe, guys.
Thank you, Bruno. Thank you, everyone.
Yeah,
Thank you, Bruno.
Yeah, thank you, everyone.
Thank you very much, everyone, for joining. Thanks, Matteo, Michelle, Chris, Noah, everyone. Really, I really appreciate all the help that you do, and especially the 11th Hour Racing, that it's supporting the SuMoth Challenge from the beginning, and we're going to continue with the collaboration until at least next year. So we're really looking forward, as said, to see all the boats racing next year here in Garda. So meeting in 1 year with racing. What do you think about it? Good deal.
Excellent.
Thank you very much.
Thanks, everyone.
Bye, everyone.
Thanks. Bye.